Hi, welcome to Wise Guys. Force and motion. Newton's law of motion. This video is talk about vertical motion. Let me show you an example. A 70-kilogram person is standing on a scale in an elevator. What is the reading of the scale in newtons if the elevator is A. moving down at a constant velocity of 1.50 meters per second, B. accelerating up at 1.20 meters per second square, C. decelerating up at 1.20 meters per second square. So first of all, we need to make free body diagram for the person. The person is standing on a scale. So there are two forces. One is Fg, which is the gravity. The other is normal force. The normal force is from the scale and exert to the person. Question looking for the reading on the scale. Actually, the reading on the scale is the force is F normal prime. Because the person standing on the scale push the scale down, so the reading is on the scale is F normal prime. But this force is equal to normal force, which is from the scale to the person. These two forces are equal magnitude and the opposite direction, and they're acting on two different objects. So this is Newton's third law. So looking for the reading on scale, Fn prime actually is looking for the normal force. And from the free body diagram for the person, there are two forces. One is Fg, one is normal force. Question A is moving downward at a constant velocity. Constant velocity means, because constant velocity, that's why the net force on y direction equals 0. So acceleration equals 0, that's why it's moving constant. So net force equals 0. That's why we see these two forces are equal. So normal force equals Fg, which equals mg, equals 70 kilogram multiplied 9.8 meter per second. So F normal force equals 70 multiplied 9.8. The number which is we can use calculate to calculate the magnitude equals 686 Newton. 686 Newton. The question B is looking for the reading on the scale when the elevator is accelerating up at the 1.2 meter per second square. So we can say accelerating up. That means the velocity is, we still have these two forces, right? The velocity is up and accelerating, that's why the acceleration also is upward. So in this case, we follow accelerating upward, that's why we set up is positive. So from Newton's second law, F net y direction equals MAY equals 1.20 meter per second square. The net force is up is positive, so we have normal force plus negative Fg equals MAY. That's why normal force equals, move Fg to the other side, plus MAY. We can calculate Fg is 686 Newton plus 70 kilogram multiply 1.20 meter per second square. So normal force after calculation is 686 plus 70 multiply 1.20. We got 770 Newton. So we can see in this case the reading on the scale, that means because accelerating upward, that's why the reading on the scale is greater than the Fg, which normally we're talking about the gain weight. The question C, we're looking for the reading on the scale when the elevator is decelerating up at 1.2 meter per second square. So the free body diagram, still two forces, Fg downward, normal force upward, and moving upward, but decelerating means acceleration downward. We follow the direction of accelerating. We said downward is positive, so net force on y direction equals MAY. The AY equals 1.2 meter per second square. Because this situation we said downward is positive, we always follow the direction of acceleration. So downward is positive, so Fg plus negative Fn equals MAY. So we have normal force. We can move normal force to the right side, move MAY to the left side. So we have F normal force equals Fg subtract MAY, which equals to the Fg is 686 Newton subtract 70 kilogram multiply 1.2 meter per second square. So we got the answer is, this situation is 602 Newton. So in this situation, because the elevator even is moving upward but decelerate, that's why the reading on the scale is less than gravity, which is losing weight. So this is presented by Wise Guys. Thank you.